Hey guys, this is JB Mom from Planning Scenes Tutoring. In this video, we'll be reviewing Descartes' rule of signs. Don't forget to use my referral code JBMon20 to get 10% off on your next tutoring package. So Descartes' rule of signs is used to determine the property of the roots of the polynomial. It doesn't matter how big the polynomial is, we can always be using Descartes' rule of signs to figure out the number of positive negative, and imaginary roots of any kind of polynomial. So let's try it out with an example right here. So in Descartes' rule of signs, you would start off with a function, f of x. In this case, our function is a polynomial to the third degree. Now, to figure out the number of positive roots in this polynomial, you would need to figure out how many times does the sign of each term change inside of this polynomial. So right here we can clearly see we started off with the positive sign for the positive 2x cubed. It switched out to being a negative once. Now this negative switches out to being a positive x value. It changes from positive 2x cubed to a negative 3x squared to a positive x, and now this positive x goes down to a negative value. So in total, we switched 1, 2, 3 times. What this means is we can have a possibility of 3 positive roots. Now, when we actually do this, when we actually use Descartes' rule of signs, we actually want to make a table of all the possible roots possible. Now I'll label it with I, the imaginary roots, the positive roots, the negative roots, and the total number of roots possible. Now the total number of roots possible is the one that you can easily see. That's going to be the highest degree of each polynomial. The total number of any polynomial is just the highest degree of that polynomial. So in this case, it's 3. So in this case, the maximum number of roots we can have is going to be 3. Well, we just found out that there could be 3 positive roots. Now, this does not mean that there has to be 3 positive roots. It's just there could be 3 positive roots. Well, if the maximum number of roots that this polynomial can have is 3, and you have 3 positive roots, that means you can't have any imaginary roots or negative roots. Now, we can also figure out the number of negative roots by using f of negative x. Well, if f of x is equal to 2x cubed minus 3x squared plus x minus 3, we can figure out what f of negative x is. By plugging in negative x for x. So this would get me 2 times negative x cubed minus 3 times negative x squared plus x minus 3 plus negative x. All right, so if I try doing this out, if I try expanding this out, I would be getting negative 2x cubed minus, well, negative x squared is just going to get me an x squared, minus x minus 3. Well, how many times does the sign change here? It switches from a negative to a negative. Nope, it does not. There is no sign change here, nor is there a sign change there, nor is there a sign change there. So there are in total 0 sign changes in the negative value. So the maximum number of negative roots that we can have is 0. Well, that still clears up with the negative number of roots that we started off initially. Now, remember I said the maximum number of positive roots is 3. So for any polynomial, there's no real way to figure out the number of imaginary roots like this. However, we do know that imaginary roots, they always come in as pairs. They always come in as conjugate pairs, complex conjugate pairs. So there has to be an even number of imaginary roots. You can have none, you can have 2, you can have 4, but you can't ever have 3, 1, or 5. ... So instead what we can say is we can have 1 positive root and 2 imaginary roots for a total of, well, 3 total roots. But no matter what we do, we can't have any negative roots because when we tried out f of negative x, we couldn't find any roots at all. So now the benefit of what we can do here is if we utilize the rational root theorem to find what the possible roots are, you don't need to test out every single one of them. Now you know which ones you might want to test out. You know that you can't get a negative value, so you don't need to test out any of the negative numbers. Now you only need to try out the positive numbers, and you know for a fact there is going to be a positive value. No matter what you do, you're either going to have either 3 or you're going to have 1. You're going to have at least 1 positive root. So you could just try out all of the possible positive roots, and you would be able to find at least 1 positive root for f of x. All right, let's try that for this function. In this polynomial, I actually set the order a little off. So whenever you're actually working around with Descartes' rule of signs, you actually do want to make sure that the polynomial is in the appropriate order, as in the highest degree comes first, lowest degree, or the constant term is going to be last. So here our highest degree is going to be negative 3x to the 5th. So f of x would equal negative 3x to the 5th. Our next value would be negative x to the 4th plus 7x cubed plus 2x squared plus 2x minus 3. Well, to find the positive roots, well, before I start finding the positive or negative roots, we already know that there's going to be a total of 5 possible roots because that's the highest degree. So the total number of roots we are going to have is going to be 5. Now we can figure out the maximum number of positive roots. To figure out the maximum number of positive roots, we can check how many times does the sign change. The sign does not change from negative 3x to the 5th to negative x to the 4th. But it does change between negative x to the 4th to 7x cubed. So that's 1. Now it does not change from positive x to 7x cubed to 2x cubed, or 2x squared, nor does it change from 2x squared to positive 2x. But it does change from 2x to negative x, or to negative 3. So that's a total of 2 sign changes, which means the total number of positive roots that we can have is 2. All right, now before we try and guess out the maximum number of negative roots or anything, we should also write down what f of negative x is going to be. Well, f of negative x is just going to be negative 3 times negative x to the 5th, which is going to give me a positive 3x to the 5th, minus x to the 4th, minus 7x cubed, plus 2x squared, minus 2x, minus 3. Well, here we can see there is a sign change here, that's 1. No sign change here. There is a sign change here, that's 2. Sign change there, that's 3. No sign change there. So the maximum number of negative roots that we can have is 3. So we can have 3 negative roots, 2 positive roots. Well, that adds up to being 5. and that gets me 0 imaginary roots. Well, since the maximum number of negative roots is 3, and we can also go down and say we can also just have 1 negative root, which means we can still have 2 positive roots. Instead, we can have 2 imaginary roots as well. So that gives us 5 as well. Another possibility that we can do is 1, 0, 4. Remember, I said 2 is just the maximum number of positive roots. We don't necessarily need 2 positive roots. We can also have 3, 0, 2. This also adds up to being 5. Well, looking at all of this, we know for a fact that there is going to be at least 1 negative root for this polynomial. Because of that, we can use the rational root theorem and plug in at least 1 negative number, and we should be able to get some root. Alright, now let's actually test out whether or not this really does work. So this is just a simple quadratic equation, and we can figure out what the roots are for this function just by using the quadratic equation or factoring it out. But regardless of what method you use, you would be getting x is equal to -2. Reason being, this is an example of a perfect square trinomial. So this is going to be x plus 2 times x plus 2, and that just means x plus 2 squared. So the only real root here is going to be x equals -2. All right. Now, if I try using, so I'm just going to write that function again. If I try solving for if I try using Descartes' rule of signs here, I'll see that I'm going from a positive to a positive to a positive. That means there are 0 sign changes here. So if I'm drawing out my table, I get I positive, negative, total. I have up to 2 possible roots. So 2 is here. I have a maximum possible number of 0 positive roots. And let's plug in f of x equals, or f of negative x. Well, that's just going to be x squared plus, or actually it's going to be a minus 4x. Squared minus 4x plus 4. That's going to be 1 sign change, and that's going to be the second sign change. So you can have a maximum number of 2 imaginary roots, which leaves me with 0 imaginary, or 2 negative roots, which leaves me with maximum of 2 imaginary roots. Now I could have also had a possibility of just having 0 negative roots, but I already know that the maximum number of positive roots is 0, so that's going to be 0 as well, which leaves me with 2 imaginary roots. So no matter which way I approached, I would have either had 2 negative roots or 2 imaginary roots. Well, it was more likely to be, or if we tried using the equation here, we would have found out it's going to be 2 negative roots. All right, that's going to be it for this video. Thank you all for watching. I hope you guys learned something new.